Hello and welcome to other group project. My name is Maria Bageva and I'm going to give you a brief introduction of what we have done for this project. Let's start with a flowchart that shows other process. So first we took the data from one of our previous classes. The data has the history of houses prices and different houses characteristics. So we imported the data, then we transformed the data, cleaned the data, and after that, they split the data into training data and testing data and worked on creating the models and testing them. So we had 4 models, which is linear regression, decision tree, random forest, and gradient boosted. And after that, once we got all 4 models, we compared to see which model is the most accurate in this case. So let's go to the code. Here you can see how we imported and transformed the data. We also did some visuals to show how the variables, if you go a little bit, okay. So here you can see the histogram of prices for the houses and also the scatter plot of the square footage versus the price. Also, we created the residual plot of linear regression model to see how the predicted values are distributed. We also compared the distribution of bedrooms and bathrooms. So having visualized the data, we also have the graph that shows the importance of each house feature. And Kevin's gonna continue.
Hello, my name is Kevin Sanchez. I will walk you through us transforming, cleaning, and splitting the data. So first is important for us to note the schema of what each variable is. Looks like here, most of them are integers or numbers. In our next line of code, we look at anything that is blank. So this is just showing us any blank lines in here. For command 11, we could see where we drop these variables. We call in some of the linear regression pipelines, vector assemblers that we're going to need. We take a look at what all the columns are named, and we created the vector assembler based on this to create 2 columns, one that will have all the input variables, and then one that have all the just the featured variable that we're trying to predict. We will use this DF assembler feature later on in the pipeline, and Zandre is going to help us explain that. So just to take a look at the data right now, it looks like it's 21,605 rows, 19 columns. Once we split the data, you see that the trained data becomes 15,000 and the test data becomes about 6,447. So after that, I'll let Sandra take over so he could walk you through the models.
Thank you. So for this analysis, we did 4 different models, starting with a simple linear regression. So here on this cell, command cell, you see us set up linear regression with looking at price. Going down to the next cell, we create a pipeline using the vector assembler that Kevin previously mentioned. And in that pipeline, first we use that vector assembler, then we actually run the linear regression. After that, we train the model and also run the assembler. And then we go down to our prediction. We've created our prediction. in this cell. Then we import a regression evaluator with the regression evaluator for the linear regression. We look at price, prediction, and the metric we want is RMSE. Then we get our RMSE in the, we evaluate the prediction, and then we print the RMSE, which is 199,483. And we'll use that RMSE later on to compare all the other regressions. Then we decided to do a decision tree. So similar process. We imported the decision tree regressor. We set up the decision tree model. We ran our pipeline similar to previous. We use the assembler first in the sequence, and then we run our decision tree. We train the model, we make our prediction, and then we go down here. You can see we did a little sample of comparing prediction and the actual price. Just a good gut check to see where we're at. Then we import the regressor evaluator again. And then we evaluate the regression with the intent to get the RMSE. The RMSE for the decision tree is $192.79. Then we go down to doing a random forest regression. Same thing here. Set up our model, create our pipeline with the assembler, as well as the random forest model that we've created. Then we train the model, we go down to our prediction, we get our prediction, and then we go down to the evaluator, the regression evaluator, to get our RMSE. And then we get our RMSE of 172,690. And finally, we do a gradient boosted regression. And here we get our model for the regression. We create our pipeline, same like the 3 times before. We train our model, we get our prediction, and then we evaluate the prediction to get our RMSE of $149.51. And here, this last piece of code, I just printed out all the RMSEs for all the regressions that we ran. And you can see that the lowest RMSE, which would show that the regression is closer fitted to the data set than any other regression. So lower RMSE is what we want to show that it's a better regression than the others. And that would be the gradient boosted tree with $149.51. Sorry, $149,051. Thank you.